Hello friends, in this lecture we will learn how to perform 3-point bending test in ANSYS Workbench. In the previous lecture we had learned about some basic concepts of 3-point bending. Now let's understand how it is performed in ANSYS or any FEA software. So we are taking this problem. Here we have a beam. So this beam is made of certain material. Now this beam is supported by these two rigid support. So we can see this is the rigid support and diameter of this is also provided similarly here. The load is transferred from this vertical direction and the load is transferred through this roller onto this top side. The dimension of this plate is given like this and all the dimensions are in mm or millimeter. Now in this problem we are going to consider all the three types of nonlinearity. First we will consider the effect of geometric nonlinearity. Second we take the material nonlinearity, and third one we will take the contact nonlinearity. So that is a difference between the simple tensile test and the 3-point bending test. In 3-point bending test we can also consider the effect of different types of nonlinearity. We can also perform in the material nonlinearity, we will insert the value of plastic deformation. So here this is the property of nonlinearity. Here we have the material nonlinearity here. So the value of density is given for this material. We have value of E and nu. Now here we have a graph between stress and plastic strain. So generally the graph is like this. When we have linearity, the graph is like this. But since we have nonlinearity, the graph will be like this. So we need to define certain points. Okay, in this way we need to define these points. So these points specifies all the values of stresses with respect to the plastic strain. So here is a physical setup of 3-point bending test. Here we can see we have this roller support from here. Similarly on the other side we have a roller support. On the mid side we are applying a vertical downward load using this roller here. So basically we are compressing it from the top side with this machine. So now we are going to perform this analysis. So let's go to ANSYS. So first of all we will have to select static structure, and then after that we need to define the material nonlinearity. For this I will go to engineering data and then edit this. Here we need to define a new material. So let's say our material is, so give it some name like this is 3-point bending material. Press enter and then I will specify its density and then isotropic properties, and then I will define its nonlinearity. So I will select multilinear isotropic hardening. So pick and drag this. So the value of density is 7850 kilogram per meter cube. Young modulus is in megapascal, so this is 2 and 5 zeros. Press enter. Poisson's ratio is, so the value of Poisson's ratio is 0.33. Press enter and then click on this tabular data. Click on this. Here we need to insert the graph for plastic strain and then stress. The stress I want to specify in megapascal. Plastic stress is in mm by mm. So select proper units mm by mm. Now insert all these values. So for 200 this is 0. So insert value 200 here and this is 0. and then press enter. Once again, for 240 this is 0.0235. Again insert this value of 280. So here this is 280, 0.0474. For 340 this is 0.0935. For 380, 80, this is 0.1377, and for 400 this is 0.18. So in this way we have defined the plastic nonlinearity, and here we can see our curve is nonlinear. So since we have defined the material, I will click on this, close this, and then we need to insert the geometry. So click on the geometry, right click, and then go to design modeler. Go to this file and import. Select this 3-point bending one file and click open. Click on generate. So now the part has been imported. I can close this. So go to file and close this. After that we will have to apply the loads and boundary condition. So we will continue this in the next lecture.